Hello everyone, my name is Yohana Amos. I am the member of group number 45 and we are going to present on the engineering a lactase-producing probiotic for managing lactose intolerance. Yes. The slide is not moving. Let me stop sharing, then I will share it again. Okay. Okay. Let me start afresh. Hello everyone, my name is Yohana Amos. I am a member of group number 45 and we are going to present on the engineering a lactase-producing probiotic for managing lactose intolerance. Do you know that lactose intolerance affects almost 65% of the global population and is mainly caused by the deficiency in lactase fluorizing hydrolase enzyme, which is needed for lactose digestion. And as we know that lactose is mainly found in dairy products like milk, yogurt, cheese, and etc. And the impact of this deficiency is lead to digestive discomfort and reduce the quality of life, and it mainly cause loss of important nutrients which are found in these dairy products such as calcium and vitamin, which are essential for our health and body function. The current managing strategy for preventing this or for managing this lactose intolerance is to not to take this daily product, that is dietary restriction. It is good, but limiting nutrition intake because we cannot get important nutrients which are found in dairy product. Another management strategy is to use this lactase supplement or lactase pills or capsules. It is effective, but the main challenge of this method is costly because we need to take the lactase supplement with every lactose contained meals. So we need to come up with new approach or new method to overcome these challenges, and that method is come up with genetically engineered probiotic. With this method, we can engineer bacteria such as Staphylococcus thermophilus, which is commonly bacteria used in yogurt and cheese production, to produce the lactase enzyme and be used as probiotic for managing lactose intolerance. The benefit of this bacteria, it is safe to generally recognized as safe bacteria, and it is beneficial for our gut. It also provides continuous relief, and also it will also improve digestion, dietary flexibility, and generally improve the quality of life. In our methodology, we suggested to use a gene which is Lactase gene, and this Lactase gene is a gene which encodes the lactase enzyme or beta galactosidase enzyme, and we'll obtain this gene from the E. coli. Why? Because is for its high lactase activity. And the genetic engineering approach we chose is golden gate assembly because all the reactions are conducted are conducted within the one tube, and the vector construction method involves different components such as plasmid, such as PNZ 148 plasmid. Why we choose this plasmid? Because it is compatible for our bacteria and it has multiple cloning sites for easy gene insertion. And the promoter that we chose is P23 because it has high strong constitutive activity for this lactic acid bacteria. And we have to choose the antibiotic resistance gene, which will such as chloramphenicol resistance gene, which will enable us to perform the selection of transformed cells. And the restriction enzyme we are going to use is type 2 restriction enzyme such as EcoALA1, which is used to to create the compatible stick end for gene insertion, and ligase enzyme for joining this this stick end fragment. Welcome my fellow to proceed. Hello? John? Hello? Hello? Oh.
Hello?
Yes, we can hear you. Oh.
Okay.
Yeah.
Yes, can you hear me?
Yeah. Yes, we can hear you.
Okay. I'll be proceeding with transformation, verification, and implementation for the experiment on gene engineering. Our method is ectopolation, and this one involves hello?
Yes, I can hear you.
Okay.
Proceed.
This
Yeah.
method involves extrapolation. Yeah. Yeah. Extrapolation, and this extrapolation tends to increase conductivity of the cell membrane and allow the interest of plasmid into the cytoplasm. How can we know that this method has been achieved? We use a PCR and a sequencing to confirm that like the gene has been inserted into the genome of the of the strain. And access to look about production of active lactase. Methods of testing either we use in vitro, we look about the activity measurement is assessed through the gut condition. And as for the in vivo testing,
Hello. We cannot hear John. John, can you proceed? Hello? Hello? John, can you proceed? Oh, what can we do? Can we start a fresh show?
Can you hear me, please?
Yeah, we can hear you.
Okay, let me. Did you hear me? For the first presentation on the slide? Hello?
Yeah, we can hear you.
Hello?
Yes.
Okay. Yeah. This is a pathway for the lactose metabolism. As we know, Streptococcus grows in the presence of different amino acids for it to grow and metabolize, break down several nutrients for its growth. Lactose and the galactose are the major nutrients which is needed for the strain to grow. And lactose and galactose are always found outside, I mean extracellular of the cellular membrane. So they tend to be shuffled into the cytoplasm through a carrier pathway, and this involves like EF, like S, GAP, P, or like S. And mo mostly like lactose, most strains of Staphylococcus homophilus they tend to thrive on lactose, and some of others they do not uh, ferment galactose. So there are three major pathways which are being utilized by Staphylococcus, and this includes tactose 6P pathway and the Leroy pathway and the glycolysis. When lactose back to the previous slide, please.
Okay.
Yeah. Okay. When lactose is inside the cytoplasm, several genes are expressed so that several enzymes are expressed for the metabolism of lactose, and the major product which are to be produced is lactate, and lactate enzymes or like LM enzymes are being produced so that uh, lactose is hydrolyzed to produce glucose for the production of energy. Yeah, sure. Next slide. There are several advantages and disadvantages for this design of experiment for the genetic engineering. For the advantages includes continuous enzyme production. This provides ongoing lactase production in the gut unless lactase pills that must be taken with each meal. Also natural and sustainable because it integrates seamlessly with the gut microbiota, offering a natural approach. And lastly, it improves quality of life. How? It enhances dietary flexibility and allow overall well-being for the individuals with lactose intolerance. For the disadvantages, uh, first of all, it is regulatory challenges because there is some regulatory hurdles in approving genetically modified probiotics either in Tanzania or in other African nations because most of ethics and some biosafety have been has not accepted generally about GMOs, which are probably due to by safety of the individuals or people in concern. Also, a consumer acceptance. Some consumers may be skipping about using genetically modified organisms mm, due to the ethical concerns and different safety concerns which are being rising currently. And the last is stability and efficacy, ensuring the stability and effectiveness of the engineered strain in different gut environment over the time could be a challenging factor.
Mm. Hello.
Okay.
Nice.
Yeah.
Yeah.
Okay, computing technology. Can you hear me?
Yeah. Yeah. Yes.
Yeah,
Yes, we
sure.
can.
Hello?
Yes, we
Yes.
can hear.
Okay. So for the engineered probiotic, it's more convenient as compared with lactase pills because for each diet, for those who are lactose intolerant, for each diet they take, they have to take in the lactase pills. But for this probiotic, it's engineered to continually produce the lactase, so it's more convenient. And then with cost, once you pay for this engineered product, you're going to continually use it as compared with the lactase that you have to like purchase each time you need it. And then with the effectiveness, the probiotic is more consistent. It gives you sensory and improved digestion compared with lactase pill that has little discomfort. And then for biosafety, the next slide. Biosafety risk. Hello. The next slide, please. With biosafety risk, so we're talking about horizontal gene transfer. So with minimizing the risk of the lactase gene, so it's transferring to other gut
I think our connection is not good, so she's not here. So what can we do? Just remedy with one slide. Hello, Evelyn,
Okay.
can you continue?
So for the biosafety rate, yes, please. Horizontal gene transfer. So we are going to assess and minimize the risk of the lactase gene getting to other parts of the gut microbiota to avoid any contamination or pathogens getting into. And then we have probiotic safety. We are going to engineer the probiotics so as not for it to have any effect adversely in the gut microbiome. And then regulatory compliance, we are going to make sure we comply with all biosafety regulations so that to ensure consumer safety, to prevent any discomfort or harm to the consumer. And in conclusion, this genetically engineered probiotic that we use using streptococcus. And this engineered probiotic is going to give effective lactose, it's going to be very effective for lactose intolerant people. We are hoping that using the Streptococcus thermophilus, we are going to hope that it is going to be safe and compatible within the gut microbiota. And then it's going to provide a natural, sustainable, and convenient alternative to other lactose supplements. And then we hope that it would have the potential to improve the quality of life for individuals who have lactose intolerance, so for them to be able to be comfortable in taking diets that have any dietary sources for dietary flexibility and digestion. And these are the references. Thank you. Thank you.
Okay.
Calm down.